Shown above is the graph f of x equals tan x. Okay, I see it. Normal looking tan x, period of pi, goes through 0, 0, repeats every pi. I like it. It gives us the interval of negative pi over 2, 3 pi over 2, If g of x is this same exact thing minus 3, what is the equation of the line connecting the inflection points? Well, hold on, timeout. So basically, let me try to sketch this. What it's saying is I'm going to have a new function where this is going to be the same exact graph minus 3. What does that mean? That means this shifts down 1, 2, 3. Now, what is an inflection point? An inflection point is where my picture changes concavity. Well, right now, my green picture is concave down, and then all of a sudden here, it changes to concave up. Now, if all of these, or rather, if both of these were to have the same shift, okay, let me quick sketch this out and move it down, then what's going to happen is all the inflection points, 1, 2, 3, all the inflection points are going to happen at the same exact area. They want the equation of the line connecting the inflection points. All right, well, here's a line connecting the inflection points. This is a horizontal line that goes through negative 3. And the equation of a line that's horizontal and goes through negative 3 looks just like that. And if you're thinking, that's kind of like the midpoint, isn't it? Or the midline, I'm sorry. That's kind of like the midline, isn't it? Yeah, it kind of is. It kind of is. And I think that's what the question they were asking is supposed to be. And so I just kind of did a little deeper dive into it. But yeah, that's what you get. It's kind of like the midline.